I'm going to hit enter, and that would give us an angle of 75.4 degrees. For the second example, I'm asked to find an angle in radians this time. So keyword here is angle that has a tangent of 0.25. I want to make sure that I'm in the right mode, right? Whenever you use a trig function or an inverse function, you want to make sure you're in the proper mode. I should be in radian mode, so I'm going to go into mode, change the mode to radian. I'm going to go back to my home screen. In order to find an angle that has a tangent value of 0.25, I'm going to use the arc tangent, or the inverse of tangent. So I'm going to use second and tangent, which is the inverse of tangent, 0.25. And I have theta is equal to 0.24. So an angle of 0.24 radians has a tangent value of 0.25. Okay. So the key thing here is whenever you're asked to find an angle, you'll use an inverse or arc function. Okay, so any questions about the inverse functions? All right, now this is how we will actually use the inverse functions. In the very next section, okay, this is the applications of right triangle section. And in this section, we'll simply be solving a right triangle. And in order to solve a right triangle, that simply means to find all of the angle measures. So whenever you were finding angle measures, you would use those arc functions. And to find all of the side lengths. So remember, when you're using the basic function, sine, cosine, that sort of thing, you're finding the side lengths. So we're going to take a look at a few examples. The first one we're going to take a look at is the example on the slide. We're given this right triangle. And I'm going to go to the document camera in a second and draw this figure again. But there's one thing about the triangles that's a standard thing, and it's called standard labeling of triangles. In this section, for some of the figures, you'll be given triangles. And in other questions, you'll be given dimensions. You won't be given a triangle. You'll have to sketch the triangle out. For all of the triangle sketches, we use what's called standard labeling. And standard labeling for a right triangle or any triangle is that your angle measures should be in capital letters. So notice as we look around this right triangle, I have capital A, which is angle A, a capital B, which is for angle B, and a capital C, which is for angle C. Now, normally in the problems, they're going to always set the right angle equal to C. Standard labeling also consists of the sides that's opposite your angle have the corresponding lowercase letter to represent the side length. For example, across from angle C, I have side length C. So notice the lowercase letters represent side lengths. the uppercase letters represent angle measures. If I take a look at angle B, the side that's opposite angle B is side length B. And notice it's denoted by a lowercase letter. And then lastly, my side that's across or opposite from angle A is side length A. And so whenever you're asked to sketch out a triangle, you must label it by using what's called standard labeling. Okay, so I'm going to go back to the document camera and I'm going to redraw this figure. Okay, so here is the triangle. This is angle A and it is 34 degrees, 30 minutes. This is angle C, which is my 90-degree angle. The side opposite angle A is side length A. Here I have angle B. The side opposite angle B is side length C. And then my side that's opposite angle C, which was my 90-degree angle, gives me my hypotenuse. Okay, so that's side length C and it's 12.7. Okay, so just a couple of things when you're solving a right triangle. So here I have to find angle B. I have to find side length B and side length A. In the problems, they'll kind of guide you through which thing you should find first, second, or third. Okay, but without that, there's just a couple of facts. The first fact is there are 180 degrees in any triangle. So if I'm given two angle measures, I can find a third angle measure by using what's called the sum rule, right? Which says that all of my angles should add up to give me 180 degrees. So based on the given information, we could find angle B. You could also use a Pythagorean theorem. In order to use a Pythagorean theorem, you would have to be given two sides, right? I would have to be given two side lengths, and I can substitute those into the Pythagorean theorem, and I could find the third side length. So just by knowing that fact, I'm given two angles, and I can find the third angle by using what's called the sum rule. So the first thing I'm going to do is I'm going to find angle B. So there's a couple ways I can find angle B. I could add these two angles together, subtract from 180. Or I could use the fact that if this angle is 90 degrees, and if there are 180 degrees together in my triangle, these two angles should add up to give me 90. So I'm going to find angle B by using that fact. I want 90 degrees minus 34 degrees, 30 minutes. And that would give me the measure of angle B. So I'm going to use a calculator. And I'm just going to make sure that I'm in degree mode. Okay, even though I'm not using a trig function, it's just good practice that if you're working with degree measures, you should make sure your calculator is in degree mode. All right, so I'm going to enter this in as 90 minus 34 degrees. 30 minutes. All right, so that's 90 minus 34 degrees, 30 minutes. Notice that it gives us 55.5. We can convert this to degrees, minutes, and seconds by going back with an angle. My fourth option is the DMS option. And we have 55 degrees, 30 minutes. So angle B is 55 degrees, 30 minutes. Okay, so now I want to find either side A or side B. Once I find one of the sides, I can use the Pythagorean theorem to find the third side. Okay, so you have some options at this point. I'm going to find side A. So now this is the point where you might set up your measurements one way, your classmate might set your measurements up another way, but in the end, all your values should match. Okay, so I'm going to find side A. The first thing I need to do is set up a trig function, all right, because I can't use Pythagorean theorem to find side A, so I'm going to set up a trig function. Whenever you set up a trig function, you want to use Chief-Sokotoa. So here are the steps to set up a trig function. The first thing you want to do is you want to choose a reference angle. Now keep in mind that a reference angle is any acute angle. So you want to choose either angle A or angle B. You never choose angle C. Since I know the values for both A and B, it does not matter which angle I choose. However, you must choose an angle. So I'm going to choose angle A as my reference angle. So I'm going to highlight that by using the curvature. Once you choose a reference angle, the second thing you should do is label your sides. And when I say label your sides, you want to label by opposites, adjacents, and the hypotenuse. So the first side I'm going to label is my hypotenuse. And remember that the hypotenuse is always opposite your right angle. So in this triangle, my hypotenuse is side C. So I'm going to label that as the hypotenuse. To label my opposite and adjacent, I want to take into account my reference angle. So my reference angle is angle A. The side that's opposite angle A is side length A. So side length A is my opposite. So I'm going to highlight that. And then lastly, B is my adjacent. All right, so we've chosen a reference angle. We label our sides according to that reference angle. So now we're going to set up our trig function. So we're going to set this trig function up by using Chief-Sokotoa. So just to review this in the slogan Chief-Sokotoa, it alludes to the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So if we're finding side A, what function will we use? Well, we want to make sure that whatever function we use, there's only one unknown, because if there's only one unknown, we can solve it for our unknown. So I'm going to use angle A. I have to use my opposite because that's what I'm trying to find. And I'm also going to use the hypotenuse. So for my opposite and my hypotenuse, that would give me a sine function. So I'm going to set this up as A is equal to the sine of 34 degrees, 30 minutes, is equal to my opposite, which is side length A, over my hypotenuse, which is 12.7. I'm sorry, I guess to cut out on the confusion, I shouldn't have actually written this. So the sine of 34 degrees, 30 minutes is equal to A divided by 12.7. The next thing I want to do is solve for A, so I'm going to multiply both sides by 12.7. And now I'm going to simplify. So in the calculator, we want to make sure that we are in degree mode. So I'm going to just double check that I'm in degree mode. I'm going to put in 12.7 times the sine. And I'm not finding an angle measure, so I'm not using an arc function. I'm using my sine function. 34 degrees, 30 minutes. And we have a value of 7.19. So 7.19 is equal to side length A. So A is 7.19. And lastly, I'm going to find side length B. I'm going to do that here. So we're going to find B. So in order to find side length B, I could use so we have C squared is equal to A squared plus B squared. C is equal to the square root of A squared plus B squared. A is equal to the square root of C squared minus B squared. B is equal to the square root of C squared minus A squared. All right, so I believe we looked at these formulas. We just had X, Y, and R instead of A, B, and C. So I'm going to use this formula to find side length B. So B is equal to the square root of C squared minus A squared. C was 12.7 minus A squared, and A was 7.19. And I'm just going to enter this wholly in my calculator. So in my calculator, I'm going to put the square root of 12.7 squared minus 7.19 squared and we have 10.47. So side B is 10.47. All right, so any questions about that first example? Or the first example solving a right triangle? So just to recap, here are the steps to set up a trig function. Okay, if you're given two angle measures, you can find the third angle measure by using the sum formula. And if you're given two side lengths, you can use one of the Pythagorean IDs to find the third side length. However, if you need to set up a trig function, here are the three steps. You should choose a reference angle, right? And the reference angle is an acute angle. Never choose the right angle. You want to label all of your sides according to that reference angle. And then you want to set up and solve a trig function using Chief-Socator. All right, let's take a look at a couple more examples. And I'm going to share my screen. And there are a couple of problems that I'm going to look at in the homework set. I'm going to go into section 9.4. And there's problem number 8. And there's usually some questions about these problems. All right, so in problem number 8, we're asked to find the measure of the angle formed by the line passing through the origin and the pi part of the x-axis. So if we take a look at the diagram, I want to blow this up just a little bit. Notice that this is on the x and the y axis, and we're asked to find the angle formed by the positive part of the x-axis, which is here, and our line. So we actually want to find this angle measure between the positive x-axis and our line.
Excuse me, Mr.
We're given an ordered pair for our point. X is 3.5 and y is 4.7. Okay, so how do we find this angle? All right, I'm going to go back to the document camera. Okay, and here's our problem. We're given this point, and it says that x is 3.5 and y is 4.8, and we want to find this angle. All right. Okay, so if we take a look at our ordered pair of points, these are actually our length of our legs. If I were to drop a perpendicular to the x-axis, that will form an imaginary right triangle. My x value is 3.5, so that would actually give me a side length from here to here. That's 3.5. Because if I were to plot this point, I would start at the origin. Since my x coordinate is 3.5, I would move 3.5 places to the right. My y coordinate is 4.8. And I would go up a distance of 4.8. Right? In order to find this angle measure, I'm going to call this theta. Right? And theta is an unknown angle measure. So in order to find theta, and keep in mind we're finding an angle measure, so when finding an angle measure, you must use the arc functions. So theta should equal to, and if I set up my trig function, remember the steps. The first thing we have to do is choose a reference angle. So my reference angle here is actually theta, since this is what we're trying to find. After we set up our reference angle, the next thing we need to do is label our sides according to our reference angle. So the first thing I'm going to do is label my hypotenuse. So here I have my right angle. The side that's opposite my right angle is my hypotenuse. The side that's opposite my angle, that's my opposite side. And lastly, I have my adjacent side. So what trig function would we set up? All right, so keep in mind that when we set up our trig function, there must be only one unknown. So in this case, I want to set up a tangent function because I don't know my angle measure, but I know my opposite and I know my adjacent. So I want to set this up as the tangent of theta is equal to my opposite, which is 4.8, divided by my adjacent, which is 3.5. Since I'm finding an angle measure, I want to use the arc tangent. So theta is equal to the arc tangent of 4.8 divided by 3.5. And we're going to find this angle by using the calculator. Since we're looking for an angle that's in degree measure, I'm just going to check the mode on my calculator and just verify that I am in degree mode. So I'm going to put this in as the arc tangent of 4.8 divided by 3.5. And we have that theta is equal to 86 86.6. Okay, so I'm just switching strings back here. So we should have 86.6 if I round to the nearest tenth. Oh, I'm sorry. I should put that in as, I put in multiply instead of divide. Let me go back.
Okay, yeah, because I have 53.9.
Yeah, I put in a divide. That should be the arctangent of 4.8 divided by 3.5. Is that what you got? 53.9?
Yes, sir.
Yeah, that should be 53.9.
Okay.
Okay, give me a second. I'm gonna go back and just put that in. Yeah, that should be 53.9. All right. So any questions about this one? Okay, there's also problem number 9, which is the very next problem. Now, if you take any like entrance exams for anything or some basic aptitude math tests for jobs, this is a question you're going to see 9 times out of 10. And this is a question, it has a fire truck, a 13.5 meter fire truck ladder. It's leaning against the wall, and we're asked to find the distance the ladder goes up the wall. If the ladder makes an angle of 27 degrees, 36 minutes. Okay, so we're going to find the length D. Okay, and this is a common problem you see on a lot of entrance type exams. All right, I'm going to go back to the document camera and I'm going to sketch out the figure. All right, so this is what we're given. We're given a fire truck. And we're given a building. Okay, this is our ladder, and it is 13.5 meters long. I'm given this angle measure, which is 27 degrees, 36 minutes. Okay, and that's the measure for this angle. And then I'm given D, which is what we want to find. All right, so notice I'm only given 2 measurements. the length of my ladder and its angle measure. Okay, and what we're asked to find is how far up the building does the ladder go. All right, so we have to set up a trig function. So keep in mind, since I have only one side length, I can't find another side length because I can't use a Pythagorean identity. So I must set up a trig function. All right. So remember the 3 steps for setting up a trig function. The first thing you want to do is go back to my notes. Choose a reference angle. Set up a trig function. Choose a reference angle. The angle that I'm going to choose in this problem is the given angle. The second thing we're going to do is we're going to label our sides. So notice that a right triangle is formed, okay, and that right triangle would actually have a right angle here. So if we label the sides, first side I'm always going to label is my hypotenuse, and the hypotenuse is always opposite your right angle. So this 13.5 meter side is the hypotenuse. Next thing I'm going to do is I'm going to label my opposite. So I'm given a 27 degrees, 36 minutes angle. The side opposite, which is D, that's my opposite side. And lastly, I have my adjacent. So we labeled all 3 sides. The third thing I want to do is I want to set up my trig function. So remember Chief Sakatoa. All right, so remember when setting up the trig function, we only should have one unknown, right? So I know my angle measure. We have to use D because that's where we're asked to find is D. And we know our hypotenuse. So if I look at all my given information, I have to use my opposite. I'm going to use my hypotenuse because I know the value. And if I look at Chief Sakatoa, I could set up a sine function. Right? So we're going to find D. Here's our trig function. The sine of 27 degrees, 36 minutes, that should equal to the opposite, which is D, divided by the hypotenuse, which is 13.5. And now I'm going to solve it for D. All right, so in order to solve for D, first thing I'm going to do is get rid of all the fractions. So I'm going to multiply both sides by 13.5. So we have 13.5 times the sine of 27 degrees, 36 minutes should equal to D. All right, so I'm going to use a calculator to find D. Okay, so I'm in degree mode. I'm in the right mode. So this is 13.5 times the sine of 27 degrees, 36 minutes. So let me make sure I got everything in here right. 13.5 times the sine of 27 degrees, 36 minutes. And we have a value of 6.25. So 6.25 is equal to D. Right, so if I go back to the homework problem, we should have 6.25. Any questions about this problem? You'll see this problem a lot. Okay, and then the very last problem we're going to talk about is a problem that deals with an angle of what's called depression. And if I go back to the slides for just 1 second. Okay, I'm going to scroll down toward the end. Here are the angle of elevation and angle of depression definitions. An angle of elevation is from point X to point Y above X, and it's the acute angle formed by ray XY and the horizontal ray with the endpoint X. All right, so this will give you an angle of elevation. Just note with any of these angles, you have what's called a horizontal. Okay, and a horizontal be a straight horizontal east to west type line. If your terminal side is above the horizontal, you have an angle of elevation. If your terminal side is below your horizontal, that's simply called an angle of depression. There is a homework problem that deals with this concept, and it is problem number 10, I believe. Okay, we're going to take a look at number 10. I'm going to generate another example. All right, so here we're given a security camera is mounted on a bank wall so that it has a good view of the head teller, and we're asked to find the angle of depression of the lens. So we take a look at the diagram. The dashed line is the angle in which we're trying to find. Okay, so that's first off. This is an angle of depression. So notice, as far as my camera is concerned, I have horizontal, and my camera lens is below my horizontal. All right, so that's the angle of depression, this angle. I'm going to reconstruct this on another and go back to the document camera. Okay, and we're going to find that angle of depression. All right, so this is dashed. This is also dashed, and this is our camera. Okay, we're given 5.95 feet and 11.08 feet. And we're asked to find this angle of depression. Okay. Now, just one thing about this. This is the angle we have to find. They don't actually give us measurements per se for our side lengths. So what I'm going to do for this problem is I'm going to draw an imaginary perpendicular, and I'm going to form a rectangle. And in a rectangle, the opposite sides are parallel and congruent, which means that if this side is 11.08 feet, this side is 11.08 feet. If this side is 5.95, this side is also 5.95. So now I can just concentrate on this triangle. Okay. As a matter of fact, this right triangle. So in order to find this angle, we must set up a trig function, right? Because I'm given two sides. I can find the length of this diagonal by using Pythagorean theorem, but that's not actually helping me find my angle. The only angle I know is a 90-degree measure, so therefore I have to set up a trig function. So remember the steps for setting up a trig function. We have to first of all choose a reference angle, and I'm going to call this theta. So we're going to find theta. So we set up a reference angle, which is the angle of depression. Next, we're going to label our sides. First thing I'm going to do is label my hypotenuse. This is my right angle. The side that's opposite my right angle is my hypotenuse. This is my reference angle. The side that's opposite my reference angle is the opposite. So this is my opposite side. And last, I have the 11.08, which is the adjacent. All right, so I labeled all of my sides. Now I'm going to set up a trig function. So when setting up my trig function, there must be only one unknown. All right, so if I concentrate on my triangle, my unknown is my angle, which is what we're trying to find. We know the opposite, we know the adjacent. So which trig function would we use? Well, Chief Sakatoa says that the tangent is the opposite divided by the adjacent. So I can set this up as the tangent of theta. That's equal to the opposite, which is 5.95 over the adjacent, which is 11.08. Since I'm finding an angle measure, I want to use the arc tangent. So if I use my calculator, and again, I'm in degree mode, so I'm in the right mode. The arc tangent of 5.95 divided by 11.08 gives us 28.23. So I'm going to go back to the homework problem. Okay, and we're asked to round to the nearest 10, so I believe that should be 28.2 degrees. All right, so any questions about that last example? All right, so I think that's going to do it for today. Are there any questions about anything that we went through today, or any questions about anything so far in the course? All right, well, if no questions in general, I'll go ahead and dismiss class for today. I will post the lecture from the last class as well as the lecture from today. I figured out how to do that. So in Blackboard, you should see a link that says recorded virtual classes, and you should be able to click on those links and view the previous lectures. All right, well, if no further questions, I will see everyone next week.
All right, thank you.
What was that again?
I just said, all right, thank you.
Okay, all right, have a good weekend.
All right, you too.